Hello developers, let's start developing. My name is Veko and we will be taking on the second part of the 18th day of the 2024 Advent of Code. So, we finished the first half of the puzzle. We have some sort of input, or in this case that, but we're gonna split it in two. So we're only gonna take the first 12 pairs, and those 12 pairs are 12 blocks that appear in our maze, and then we need to solve the maze. Doesn't sound too complicated, and it wasn't. We did some Q and it solved it. But now we're continuing on. So it's not just those 12, it's gonna be all of these 20 or 30, how much they are. Actually, we have them here, it's 25. So the next 13 will also need to fall. And if they continue falling, they will just basically break our connection between the start and the end. We won't be able to get to the end. So we need to find at which point exactly do we stop. So the coordinates of the first byte that prevents the exit from being reachable are 6, 1. So until we get to this point, it's reachable. When we get to this point, it's not reachable. Now, I kind of don't like that because we could basically hardcode guess our way to the top, because it's like you have 2000 lines of input and one of them is the solution. Yeah. It's not like it's a 10-digit number or something to guess, but still, having 2000 guesses at Advent of Code, which actually has mechanism in place to prevent that, will get tedious. But what we can do, note that, let's take this thing, and now we're gonna extract. So we're not touching part 1, but we're gonna reuse this for part 2. So I will have something like this, where we will do some calculations or whatnot. So in order to get the grid, we just need the input. So we're gonna need to take this as a parameter. We're gonna need to take we're gonna need to take the input, and we're gonna need to take the number of blocks that will fall. So I will say find me a path, and that will be the block limit, which will be a simple number. So now, the width is gonna be a constant here, but note that the limit is not gonna be a constant, it's gonna be injected. So we will make a grid and only go up to that point. And then we're gonna solve it, and then we're gonna return our value. So what I will do here, so the low limit is actually 12, because we already know that. We already know that there is a solution for 12. So we will let the block limit to be equal to the low limit, and while the block limit is less than input.length, we're gonna find the path for this input through this block limit. And now it's really important that we are not destroying the input each time that we're going through, and we're not, since the input is only used here, and we're slicing what we need and we're setting something else. So the input stays fixed, and we're slowly increasing the block limit by 1. So we will get a result. I will actually console log the result. Block limit that, and I will also print out the input of block limit. When we get to a point when we get the max safe integer, which is the constant that we are using to say something is unreachable, then we will just return, that, but the actual solution will be this. Let's run this code and see if it does what we want it to do. It's not, because we're not running part 2. It works better if you actually use it. So at point 12, we're getting 22, 13 gives that, so point 21 gives us that. Are we correct? What is point 12? The 12th point is actually 5,1. This has index 13, and that is 1, 2. Block limit 12 goes up to... Block limit 12 actually takes these 12 boxes. So block limit... yeah, we are off by 1. And this was why I used it on the... that. So we have block 1, 1. It's this one. Block 1, 1 gives us that number, so it's not gonna be that, it's gonna be... this is actually block limit -1. I think so. It might be block limit +1. No, it's -1. So the block number 21, 6.1 gives us the result of max safe integer, which means that the 21st block is the block that we actually need. So let's go back to the huge input, and now we need to change this, that the width now becomes 71 for the big input. This is kind of weird. Yeah, we're gonna have this variable that we can change. This variable is different for each input, we can call it. And here we can just say this is global.width. Here we can say this is global.limit. And let's see if we have 7 in a different place. No, we have it here. Yeah, this is gonna be global.width. Great. Do we have 12 anywhere? Yeah, the low limit is global.limit. So that we know that we're gonna change everything, because now these numbers are 71 and 1024. Now this might get tedious, because we have a couple of thousand things to run through, and for each of those 2000s we are basically running the first part over and over and over again, and we got to that point 2899. If I don't have yet another off by an error, this should be the correct result. Let's see, and it is. Great. So other than that, what we can do, I might not want to console log everything, but I want to is unreachable. This is a special case in this case because the result doesn't really help us here because we need to return the coordinates. Let's run it and see if this thing works. Now we're gonna need to wait because we don't have an input, and that block limit is unreachable, which is our correct answer. This takes around 3 seconds, so it's not very fast, but it's not really slow. But what we are doing, we are basically redoing the same thing over and over and over and over and over and over again. But what we can do is basically use binary search here, because we know that at the point 1024 it's open, at the point 3500 it's closed. So we can go to the middle of that interval and only check there. And then depending of if that is reachable or unreachable, we're moving left or we're moving right. In that case, we would need to do up to around up to 20 checks, I would say. Now 20 checks is about 1,000,000, this is 2,000, something like 13 checks. Which is less than all the checks that we did here. But it will actually speed up our program by up to 3 seconds. It's not gonna be faster than 0 milliseconds. So we will see later on whether this we should optimize this or not. This code is relatively simple. I mean, finding the path is finding the path. But this code is relatively simple. We're just looping through each of them and looking for the first one that doesn't match. Binary search would be a bit more complicated than this. Not too much, but it will be. So for now, I'm gonna leave it as this. We have the correct answer. We have possibility to make it better if we want to, but we'll see about that. So that's it for now. Click like, subscribe, comment if you want to, and of course,